What is uncertainty in measurement? Okay, to begin explaining uncertainty, let's consider an example. Some students have filled um, a graduated cylinder with water, okay, and they filled it up to this point. And if you zoom up to where the water meets the glass, you can see that it's right around here, okay? So it's right around 21 and 22. So you have these four students, Andy, Sally, Joe, and Jason, and they take down measurements of how high the water has gone up the graduated cylinder. Andy says it's 21.4, right? Because he sees the water is definitely past 20. He's sure of that. He also sees that the water is definitely past the 21 because it's past this red tick mark, but he's not sure where exactly the water is in between here. So he's going to say 21.4. He thinks that it's around zero point 0.4 between 21 and 22. Sally says that it's 21.5. Sally also sees that the water is definitely above 20 and the water is definitely above 21, but she's not sure from there. So she says it's 21.5. She thinks the water midline is around the halfway point. Joe does the exact same thing, also gets 21, but when he comes to the last digit here, he thinks it's 21.6. And finally, Jason, exact same thing as Joe, Sally, Andy, except he thinks it's 21.3. He thinks the water is 3/10 the way up from the 21 tick to the 22 tick. Okay? Now, which one is correct? Well, in a sense, they're all correct. They all took the same measurement and they're all looking at the same water in the graduated cylinder. The difference is that the last digit people are uncertain about, and this is the uncertain digit. It's the digit that you estimate. The person who takes the measurement estimates this digit, and that's why this is called the uncertain digit. Every time you take a measurement, the last digit will always be the uncertain digit. The certain digits, okay, is the 21 over here. Everyone who takes this measurement, whether it's you, me, Joe, Sally, Jason, Andy, will always get 21. Okay, we're always going to have that because everyone can tell that the water is past the 21 tick. We just don't know if it's 21.4, 21.5, etc., etc. When we're recording measurements, we always record all the certain digits and the last uncertain digit. And the reason we don't record more uncertain digits, for example, the reason Andy didn't write 21.45 is because we're not even sure of the 4. This could be a 3. And if there's a 3, then this 5 is thrown completely off. So there's no use in having more than one uncertain digit. We can only have one uncertain digit, and that's always the last digit. That's the last digit we measure. When you combine all the certain digits and all the uncertain digits, what you get is the significant figures, the significant digits of the measurement. So in this example, we have 3 significant digits because you combine all the certain digits, which is a 21 here, and the uncertain digits, which is the 3. Okay, I say digits, but it's really just one digit, one uncertain digit in any measurement you do. I'll show you another example where you can have differences in uncertainty between measuring devices. Let's say we have a scale A and a scale B. Now if you look at the measurements of these scales, one goes 0.00 to 2 decimal places, and the balance B, I'll call this balance A and balance B. Balance A goes to 2 decimal places, balance B goes to 3 decimal places. So let's say you put some substance, you put some, the same amount of substance on both of these balances, the exact same amount. Let's say they're identical theoretically. And balance A shows 1.34 grams, says that this red substance weighs 1.34 grams. Balance B says that the substance weighs 1.335 grams. Is it because the weight the substance weighs differently? In this case, no, right? We put the identical amount of substance on each balance. The reason it appears 2 different numbers is because the uncertainty on each balance is different. This balance only reads up to 2 decimal places. So it knows for sure that's 1.3 grams at least. Okay, balance A knows for sure that the substance is 1.3 grams at least, but it's not sure about the last digit, the uncertain digit. It's going to estimate that it's 1.34. Okay, now it knows for a fact it's 1.3 grams, but it doesn't know about the last digit, so it estimates. It could If you took the same balance might come up with 1.35 or 1.36, okay? This last digit is uncertain. The balance is not sure about that digit. The 1.3, the balance A is 100% on. It knows that it's at least 1.3 grams, but it doesn't know how much after that. When you go to balance B, you can see it measures up to 3 decimal places. What does this mean? It means that these certain digits they're certain about. So balance B knows for a fact that it's at least 1.33 grams. It knows that it's at least 1.33 grams, but this last digit it's not sure about. It estimates that it's 1.335. Okay, now if you took another balance B and you weighed the same amount, it might come up with 1.336, 1.334. It's not sure. Okay, but it is 100% confident that it is at least 1.33 grams, and it is not confident, but it is estimating the last digit. Okay, now if you were to wonder which balance is more precise, then it would be balance B, because balance B can measure up to more significant digits. Okay, it can measure up to 4 significant digits. The 1.335, we have the 3 certain plus the 1 uncertain. That's 3 plus 1, you get 4. Okay, 4 significant digits. Balance A only goes up to 3 significant figures, significant digits. Those are the same thing.